Good afternoon, everybody, and welcome to another edition of How Do You Know? This is Dr. Daniel Barth, and we're glad you're here with us. So let's talk about the astronomy and space science news. Asteroid Bennu samples have been returned. One of the greatest triumphs of robotic exploration ever, the OSIRIS-REx mission has successfully, after a 7-year journey, returned samples of asteroid Bennu. This was particularly exciting because OSIRIS-REx touched down on asteroid Bennu. They had, of course, the usual suite of cameras and spectrometers on the craft, but the premier instrument for the Bennu flight was the TAG-SAM, the touch-and-go sampler. This was a sampler on the end of a mast. The spaceship lowered, and to everyone's amazement, they thought they would touch on a hard surface. They would give off a blast of nitrogen gas, which in the low gravity, they were hoping for maybe 25 to 50 grams of material if they really got lucky. But asteroid Bennu is a rubble pile. We are finding more examples that rubble pile asteroids are more common, and the TAG-SAM sampler sunk 50 centimeters into the surface of Bennu. Folks, that's for our American audience, that's more than 2 feet into the interior of the asteroid. And when they gave the blast of nitrogen gas, they excavated several tons of material, and the TAG-SAM sampler was so full they had trouble shutting the lid. They've recovered now, they've brought it back, and OSIRIS-REx went ahead and jettisoned the capsule, which parachuted safely down into the Utah desert, and people were able to get it within minutes after touchdown, and they opened it up. They found they have more than 500 grams of material, half a kilo, from asteroid Bennu. Because they were able to go so deep into the asteroid, they weren't expecting that, they believe they have recovered extraordinarily primordial material that dates from the formation of our solar system, at least 4.5 billion years old. They also found a lot of powdery black dust all over the sample interior, which they're also collecting as samples. All of this material, of course, will be very carefully curated. It was flown to a special laboratory where the sample container was opened inside a glove box under a flow of purified nitrogen gas. They're doing everything to protect these samples from Earth's corrosive oxygen atmosphere so they can study them in a pristine way. They will curate these samples. They will divide them up. There's lots of agencies and laboratories around the world that are, sending pretty please for Christmas to NASA saying, we want a piece of Bennu too. For OSIRIS-REx, it didn't land. The spacecraft flew by Earth, and it's using the last of its propellant. And that craft is now off on an adventure to take a look at asteroid Apophis. And that's the asteroid you may know. That's the asteroid that has it's one of the hazardous ones. It has a significant chance of a collision with Earth in the 2100s. And we're very interested to take a look at Apophis and see indeed if it is a rubble pile like Bennu or solid and what its makeup is. The interesting thing about Bennu, it's quite large. And Bennu is an enormous asteroid. And we've always thought that, gee, if something came like this, how would we destroy it? Or how would we possibly avoid it? Well, for a rubble pile like Bennu, if we took a warhead, a modest nuclear warhead, it would be able to penetrate right into the asteroid and literally blow it up into lots and lots of very tiny fragments, which would pose no danger. Keep in mind that if you blow up an asteroid, all the pieces keep on the same trajectory, so we would probably end up with a heck of a meteor shower, which would be very exciting to see. but we're anxious to go see asteroid Apophis. And so OSIRIS-REx has now been renamed OSIRIS-APEX for Barth Explores. So we'll be looking forward to that. Also, news from Mars. The Ingenuity helicopter has set a new record with their 59th flight. They were able to achieve an altitude record of more than 20 meters. And you have to remember, NASA told us that, well, we're hoping to get 5 flights out of Ingenuity. This was its 59th flight. So Ingenuity has now lasted more than 11 times its manufacturer's warranty. I want my next car built by NASA engineers. Thank you very much. It's flown more than 13 kilometers, which is pretty darn good. The other fascinating news we have comes from the heart of the Milky Way galaxy. Scientists looking at stars flying around the supermassive black hole, which is known as Sagittarius A star, which exists at the core of the Milky Way. They have been looking at the orbits of stars which are very tightly bound to this black hole, and they found, much to their surprise, that the orbits appear to be chaotic. Now, we look at systems like stars going around a black hole. Gee, why shouldn't they orbit in a non-chaotic way, just like planets orbit around stars? Well, it turns out that if the mass of the parent body is too much greater than the mass of the orbiting object, that indeed the orbits do become chaotic very quickly. And by quickly, we mean that they become chaotic on a matter of a century or two, and we consider that compared to our solar system, where the Earth has been stable in its orbit for at least 4 billion years. And so this was quite a surprise that, once again, we don't understand gravity as well as we think we do, because when we have this massive difference between particle and central body in an orbital situation, that when the difference is massive enough, the orbits become chaotic. Now, nobody at this point knows exactly how big a ratio you need. And of course, a supermassive black hole is one of the largest individual objects in the universe. And stars, well, they're big, but compared to an SMVH, just not that big. So another group of folks came up with one, and this one I had to read twice. They asked the question, what's the closest planet to Earth? Now, I think most of us who watch this program regularly would immediately answer that Jeopardy question and say, I know, what is Venus? And if you were looking at the planet who on average is closest to Earth, you'd be wrong. And they did quite a bit of mathematical analysis for this, but what it amounts to is simply this. If you're talking about what are planets on average closest to, the thing they orbit around. The Earth is never much more or much less than 1 AU from the Sun. And if we consider Venus, well, sometimes we are quite close on the orbit, on the order of about 1/3 of an AU. Other times, we're quite far away, about 1.3 AU away from Earth when Venus is on the other side of the Sun. And if you take a look at an average, every planet is closest to the Sun on average over time, which means the planet all of the rest of the planets in our solar system are closest to, on average over time, is Mercury. I was quite stunned by that.
Don't forget your book.
Producer Paul reminds me that our show today is sponsored by the Star Mentor book. It's coming up on holiday season. Many of us who are active in the astronomy community, this is the time friends and relatives come to us and say, oh, I was thinking about getting a telescope. Or they come and say, I'm thinking about getting a telescope for someone else for Christmas. What would you recommend? Well, one of the things we really want when our friends come and ask us to help them get into the activity of astronomy is we want them to stay in the activity. And we don't want them after a week or two with the telescope. I've seen the moon, now what I do? Oh, I don't want this hobby. It's not exciting, it's not fun. Pick up a copy of Star Mentor with your astronomy purchase. It's like having an old astronomy professor right by your side. More than 50 activities that you can sample a la carte. You don't have to go one to the next, but you'll learn how to operate your telescope, read a star map, find things in the sky, and you'll learn a lot more about what you're looking at. I've always believed as an astronomy instructor, the more knowledge you bring to the eyepiece, the more wonder and value you take away with you. Star Mentor is available on Amazon. Pick yourself up a copy today, and please don't forget to give us a nice review.
Very last time to get your solar glasses.
Yes, solar glasses. We have solar eclipse coming up on Saturday, and I did a solar observation and safety seminar last Friday for a large group of homeschool parents and children, and we have that video available for you on YouTube on the Explore Alliance page. And the science activities that I promoted there are also available for download. And if you go take a look on the Explore website, and you'll find them there. There were 4 activities: timing the eclipse, making an eclipse simulator, observing the eclipse with binoculars. And so you can type in those titles and you can find them and download those activities for free. If you know a student in your life who's interested in science, or you're just an astronomy nut yourself, I hope you'll take a look at that video and download those activities, because those are great and we want you to observe safely. As we've pointed out on this program, solar eclipse glasses are great, and we hope you've got yours. It might be a little late to order them by mail, but we have them here. What's that?
You can get next day.
Yeah, if you go next day, you can still have them. They're a great bargain. They sell 4 pairs for $10, and these are certified. Whatever you get, folks, make sure you don't get bargain brand eclipse glasses that are not certified, because you can damage your vision. And I'll remind everyone again, you cannot put on eclipse glasses and then use binoculars or look through a telescope. That concentrated light will burn through those solar glasses and damage your vision before you can take your head away. Don't do that. Solar eclipse glasses are just for looking at the sun, naked eye. If you want to look at the solar eclipse, and there's another one coming in April, if you want to look at this with a telescope or binocular, contact the Explore store, explorescientificusa.com. The reps there can help you, because we have solar filters for pretty much any size amateur telescope you wish. And again, we use only high-grade certified solar eclipse film for all our products here at
Dr.
Explore.
Barth.
So, yes, sir.
So our friend John Ray,
Yes, John. Welcome back.
he says, I'm going to purchase a copy of Sky Mentor, and once I have read it, I'm going to donate it to the local library.
That, John, God bless you, sir. That's an outstanding idea. I'm going to ask John, yes or no, are you anywhere near Northwest Arkansas, my friend?
It'll be a while.
It'll be a while. Okay. I'll just tell anybody, if you're in the area of Northwest Arkansas, if you're within driving distance, and you pick up a copy of Star Mentor, you're welcome to stop by the Explore store. Ask for Doc. Hey, is Doc here? And I'm doing educational work and product design and stuff for the Explore company now, and I will be happy to sign your copy. So if you'd like to get a personalized copy for Christmas for somebody, let me know.
New Hampshire.
New Hampshire. That's a bit of a drive, John. Nevertheless, I hope you enjoy your copy, and thank you so much for donating it to a local library. And I'll tell you what, that's going to be a great asset for your library and for the astronomy enthusiasts in your community. So we appreciate your support very, very much. So what are we going to talk about today? This is the How Do You Know show. Sometimes we talk about things that have been discovered, but a lot of what we do here is we talk about how does science work? What happens when somebody says, I have a claim, I found something new, and then the entire mechanism of science goes into high gear. Because, of course, it's not what you believe. It's not what polls best. If 97% of scientists agree, it doesn't mean a thing. What we do in science, someone says, I have data, I have results, I believe I can interpret them, and I found this to be true. Other scientists are immediately going to come in and try to either confirm or refute your claim. The idea that scientific claims are subject to rigorous debate and investigation is a core principle of science and has been for thousands of years. We can have no genuine science, my friend, when anyone in the scientific community is silenced or shamed. And science, the history of science is rife, just chock-a-block full of people who came along and said, I have a new idea. And everybody said, boo, we don't like that idea. And yet, the one was correct, and the multitude had to adjust their thinking. We think of Copernicus, we think of Galileo, we think of Kepler, we think of Einstein. Einstein was not popular when he first came out with the relativity theory. People in his own home country pretty much really didn't like him, not necessarily for scientific reasons, sadly, but they were rejecting his scientific ideas on other personal and religious bases, which is just silly. It doesn't matter who you are, where you were born, who your parents are, what your skin tone is, how you worship or don't. Science kind of is removed from all that falderall and hubbub. Science is based on the idea that if you have an idea, if you have a claim and you throw it into the arena, other people will vigorously investigate it. And if you've got a good idea, if your idea is supported by data, supported by experiment, if your theory can make successful predictions that are supported in other ways, well, then your idea will be accepted no matter who you are or where you look like. And that has also been shown to be true again and again and again through the history of science. It's not an instantaneous process, to be sure. And sadly, there are people who discover things who do not live to see their ideas vindicated. But ideas, good ideas, are immortal, and there is nothing so powerful as an idea whose time has come. Let's take a look at a new claim. This comes from, and I'm hoping I'm saying this correctly, Dr. Rajendra Gupta from the University of Ottawa. And he published a paper based on his data and research, and he said the age of the universe is approximately 26 billion years old. Now, Gupta's work quite directly contradicted the prevailing view, which is about 13.6 billion years for the age of the universe. And this is commonly accepted among astronomers and astrophysicists. But again, it's not just accepted because we like the number 13 better. It has nothing to do with popularity. It has to do with lines of evidence and data. Nevertheless, Dr. Gupta had theoretical backing and a theory that he said explained his results. He was using the theory called tired light. Now, the tired light hypothesis basically says, and this was an idea that came out during Hubble's time, when Hubble was looking at the redshift of galaxies and saying, wow, the universe is expanding. Tired light was a contradictory hypothesis, and tired light says it's not the Doppler effect, and the universe is not expanding, but what happens is light, as it leaves a galaxy, it, of course, has to work against gravitational pull, and the gravitation of a galaxy or a galaxy cluster will in fact pull on this light and lower the energy. And when you lower the energy of light, friends, you decrease the frequency and increase the wavelength. So if you start with blue light, which is quite short and the frequency is quite high, and you decrease the energy of that light, you get down across the spectrum to red light, where the wavelength is long and the frequency is lower. And in fact, a red light doesn't carry as much energy as blue light. Albert Einstein won a Nobel Prize for the photoelectric effect, not relativity. He won for the photoelectric effect, which basically said, one, light is quantized, and two, that you have to have a certain frequency or energy level of light to trigger certain reactions. Well, of course, biological scientists knew this all along. They knew that it takes certain colors of light to activate chlorophyll and create photosynthesis. And kids have done this science experiment for years showing, gee, plants don't grow well under pure red light because there's not enough energy for them to do photosynthesis effectively. But Einstein showed this with the photoelectric effect. Well, this tired light idea basically says the farther light goes, the more energy it loses, kind of like a marathon runner, and the frequency gets lower and the wavelength gets longer. Now, when we have two competing theories, tired light and universal expansion, in our show notes today, we call them the TL theory and the UE theory. When we look at this, we say, well, gee, how do we know? How do we decide between two competing theories? Isn't one as good as another? Isn't the idea of flat Earth just as good as spherical Earth? Isn't the idea, you know, and there have been theories throughout history, and yet you'll notice that you really have to dig around the bleeding edge of modern science to find something where there are competing theories. Well, when we decide between these, we basically take a look at not just how does the theory explain one phenomenon, we go farther than that and we say, okay, what does this theory or that theory predict? Ultimately, a powerful, effective theory, an accepted theory, must make predictions which are then verified by independent observation and experimentation. Galileo did this when he observed the crescent phases of Venus. And Galileo, with his new telescope, noticed, gee, as we go from a nearly full phase, a gibbous phase of Venus, toward a crescent phase, the size of the apparent diameter of the disk of Venus gets 5 times larger. Galileo reasoned that this could only work if Venus was orbiting the sun, and as it approached us, it went into these crescent phases, but it was much closer to the Earth, and so it had a much larger apparent diameter. In fact, the Earth-centered hypothesis said Venus should orbit the Earth, and so its distance should never change very much. And so the idea of this massive change in the apparent diameter wasn't supported. So Galileo's theory predicted and explained what he actually saw in the telescope. The Earth-centered hypothesis could not. And so the Earth-centered hypothesis was discarded because after centuries of attempting to explain and failing on so many fronts, this new theory, the Sun-Saturn theory, the Copernican theory, was explaining things better and making more accurate predictions, and it was not immediate. Galileo died a convicted heretic. His theory was, within the next century, accepted throughout the astronomical community as they realized the new theory was more powerful and more accurate. And Galileo was forgiven all that heresy stuff. Pope John Paul did it in 1992. So when we look at this idea, we then go to other ways of looking at the universe and saying, does it support tired light or does it support universal expansion? One of those things we look at is the cosmic microwave background. As you probably know, Penzias and Wilson discovered the cosmic microwave background in the early 60s. They received a Nobel Prize for their work. And Dick Peebles took a look at this and said, I know what that is. It's the echo of the Big Bang. And in fact, when the cosmic microwave background was discovered by Robert Wilson and Arno Penzias in 1964, they found out that, gee, this matches Hubble's prediction, because Robert Dick had gone ahead and taken a look and done a prediction. He said, well, if this whole Big Bang thing is true and the universe has been expanding the way Hubble says, well, if you have a concentrated hot object and then you spread it out over a large volume, it cools off because there's only so much heat. When you use it to fill a larger volume, well, it gets cooler. Candle is hotter at the center of the flame than it is a few inches or a few feet away from that flame. That heat disperses. And Robert Dick went ahead and predicted, he said, with his math, 10-degree Kelvin. Well, it turned out that the temperature of the microwave background discovered by Penzias and Wilson was about 3.3 degree Kelvin, and they received their Nobel Prize for that discovery in 1978. Now, the cosmic microwave background basically relies for its mathematical predictions on the fundamental theory of universal expansion. And this 3.3 Kelvin is backed up by the enhanced, you don't make a theory in 1964 and then nobody meddles with it for 50 or 60 years. Nope, that doesn't happen. What happened is that this theory has been modified and more observations have been made in the modern mathematics. Basically agree with modern observations. The theory mathematically predicts about a 3.3 Kelvin microwave background temperature. Observations find that their observations are in very close agreement with the mathematical theory within the margin of error. And so cosmic microwave background supports universal expansion, but not tired light. Tired light doesn't have any explanation for cosmic microwave background. Tired light basically rejects the idea of universal expansion, and by implication and extension, tired light rejects the idea of the Big Bang as well. And modern cosmological observation of the microwave background do not support tired light. Well, then we have other modern scientists. Alan Sandage, Carnegie Observatories. You may know of Professor Sandage. He is one of the modern giants in astrophysics and a direct successor to Hubble. And he was working with Laurie Lubin from Johns Hopkins. And they took a look and said, well, let's look at the surface brightness of distant galaxies. Well, tired light and universal expansion both indicate that distant galaxies should have a lower surface brightness than nearby galaxies. And we take a look, but tired light and universal expansion give quite different predictions for how bright the galaxies should be. Universal expansion says, and many of our viewers will know this, that the farther away a galaxy is, the faster it is receding from us. Because as Hubble discovered, and many other scientists have confirmed, it's not that the galaxies are rushing away from us through existing space. That's not the explanation. Hubble's universal expansion says it's space-time that is expanding and carrying the galaxies along with it. The classic explanation is the raisin bread explanation. If you take a loaf of dough with raisins mixed in, I prefer chocolate chips, but that's a personal matter. If you're baking bread with raisins mixed in, as the bread expands, all the dough expands, And what you'll find, since all of the dough is expanding, nearby raisins will be moving apart at a fairly slow rate, but raisins at either end of the loaf are moving away much faster because all of the dough in between is expanding. Well, if we think of the dough as an analogy for space-time, we see that throughout the cosmos, the farther away a galaxy is, the faster it must be receding from us. Well, this brings into account Einstein's relativity. Why? Because when galaxies are far enough away, they are indeed receding from us at what we refer to as relativistic velocities. When things are moving at very high speed, it has an effect on mass, on length, and on time. And so when we look at this, tired light says the universe isn't expanding at all. There should be no relativistic effects, even if someone arguing tired light accepted Einstein's relativity. Well, the tired light hypothesis says the galaxies aren't actually going anywhere. And if they're not going anywhere, we should be seeing no relativistic effects. Tired light simply says the light gets tired, it drops in energy and increases in wavelength, decreases in frequency, it becomes in effect redder, moves toward the red direction in the spectrum, but there's no room for relativistic effects in tired light. And so if tired light was correct, young galaxies, galaxies that are far away from us, where we're seeing them, remember when we look out in space, we look back in time, because it takes time for the light to get here. Both universal expansion and tired light agree with this. Well, tired light says young galaxies should be dimmer than old ones. Because to find a galaxy that's truly young, you have to look very far out in the cosmos, billions of light years away. And for that light to come there from this distance, they should be dimmer galaxies. However, young galaxies are primarily populated by, especially these very old galaxies, they're populated by Gen 3 stars, or the population generations are very odd. The numbers are kind of reversed, but young galaxies should be full of hot blue stars. They should have a much brighter surface brightness than old galaxies, where a lot of the new young blue stars have burnt out. They've gone supernova. They've seeded the environment with metals, that is things helium, lithium, and larger. And these elements contaminating, again, using loaded language here, but contaminating the pristine cosmic environment of hydrogen and helium tends to make for smaller, cooler burning stars, stars like our own sun, dwarf stars, as opposed to the blue giants from early galaxies. And tired light's prediction of dimmer young galaxies just doesn't hold up. Hubble doesn't verify it. Webb doesn't verify it. None of the terrestrially based large telescopes and arrays verify it. They all see young galaxies as bright and hot and full of blue stars, as opposed to older galaxies, which are much more full of red and yellow dwarf stars. And so, again, another line of evidence does not support Gupta. The Lawrence Berkeley Labs, they too chimed in, and they said, oh, well, let's take a look at supernovae. And this was Gerson Goldhaber, and again, hope I'm saying the names right here, friends. If I'm not, apologies. And Goldhaber and his group went and conducted a study of supernova, because supernova have this unique effect. They brighten and then they fade away. If you've taken a look and studied the idea of supernova, it's kind of like a firework. They start out very concentrated and bright, and then they fade out over a period of months and years. And we've been watching supernova 1987A in the Large Magellanic Cloud for decades now, and we've been observing its dimming as it gets older. But again, the tremendous velocities of distant galaxies brings relativity into play. when you have something moving at a relativistic speed, time slows down. This is not an illusion. It's an actual physical effect. It has to do with space-time and relativity theory. And because of time dilation, supernovae in distant galaxies, which are moving very quickly, because of universal expansion, they should flare and then fade over a longer time period, because when those galaxies and the stars they're carrying are moving very fast, their time slows down relative to us. Now, Goldhaber and his group said, let's go ahead and compare supernovae in distant galaxies to supernovae in our galaxy and other nearby galaxies. Why? Because if it's in our galaxy, it's not really moving away from us very much at all. And if it's in a nearby galaxy, like Andromeda or Triangulum, well then, gee, a supernova in one of these nearby galaxies should not be moving away from us very much at all. And if we're all members of the Virgo cluster, then the relative motion is very, very small compared to very distant galaxies. And once again, Goldhaber and his group, their predictions of time dilation because of the relativistic velocities of distant galaxies and universal expansions, their observations of supernovae in distant galaxies compared to nearby and in our own galaxy, they have found that, yes, indeed, these supernovae in distant galaxies do flare and then dim over a significantly longer period of time that matches precisely what Einstein and relativity theory predicts. And this is not only confirmation of universal expansion, it's yet another confirmation that Einstein was correct, that his relativity theory again passes another test. And we're in 2023, and general relativity was formalized and published in 1915. So we're more than a century out, almost 110 years out from general relativity theory. People have been testing relativity theory because, of course, if you were the first person to find a flaw in general relativity, you would be very, very famous and highly acclaimed. After all, Einstein himself became famous and very highly acclaimed. Why? Because he was the first man in 350 some years who actually found a problem with Newtonian gravitational theory and was able to give us a correction. So, Goldhaber's group basically, once again, comes down on the side of universal expansion and not tired light. Now, what does this tell us about the scientific process, and what does it tell us about the general media that covers science? Now, when Professor Gupta released his claim, oh, the age of the universe you thought was correct, 13.6 billion years, give or take, was wrong. It's twice that old. Well, guess what? Dr. Gupta and his theory got an awful lot of coverage. Now, some of this press coverage was very scholarly indeed, and it took a look at Gupta's ideas of tired light and what it said about the age of the universe versus Hubble's universal expansion and what it said about the age of the universe. However, there were an awful lot of, let's call them second-tier science reporting. Science reporting kind of in the vein of what I do for you, where I'm not speaking to you as I would to a fellow astrophysicist. I'm speaking to you as a citizen scientist who's interested in astronomy and cosmology and the scientific process and how it works. A lot of the second-tier media were promoting this as an amazing new discovery. Everything you knew about the age of the universe was wrong, and other sensational headlines. And these things percolate down into the general press, things like major newspapers and news agencies, and wow, a lot of them really fell flat on their face. I know you're saying to yourself, why didn't they call Dr. Barth? He could have set them straight. Well, every once in a while I get those calls. But you know what? These news agencies, I think they have an obligation to dig a little deeper, and instead of being concerned about being the first one with the big scoop, I think it would do them and their readers and their audience a much greater service to be a little more clear about the facts. Now, this does not say, oh, well, we should disregard new and extraordinary claims. That's not true at all, and that's not the way real science works, because I'm going to bang this drum again, folks. I do it all the time. Science is not a matter for polls and opinions. We have seen people from government officials, news agencies, politicians, oh, the science is settled. I'm sorry. I don't think you can ask for a bigger banner of scientific ignorance than for someone to spout things like, the science is settled. You can't question that. 97% of scientists agree. No, no, no. I feel like I'm talking to a puppy who piddled on the rug again. No, bad dog, don't do that. It's not a matter of opinions or polls. It's perfectly fine for news agencies to say, wow, there's an extraordinary new claim, and Professor Gupta from the University of Ottawa is claiming that the universe is now 26 billion years old. Obviously, viewers, readers, our audience for our news agency, obviously friends, this is an exciting claim, and if it turns out to be true and it's supported by evidence, it will revolutionize what we know about our understanding of the universe. But I'll ask our viewers to remember that science is not an instantaneous process. Extraordinary claims, I'm going to quote Carl Sagan here, extraordinary claims require extraordinary evidence, and Gupta's claim certainly falls into that category. And that's not to say that we should discard or dismiss extraordinary claims and just say, well, that's too silly, it's too far out from what we know, we can't accept that. That's unscientific too. If we prejudice ourselves and say a new claim doesn't deserve the respect of investigation, we've ceased being scientists and we've become partisans, fanboys for a particular theory or idea. There's any number of great ideas that were fascinating during my lifetime, which have been found to be not true. The idea that dinosaurs were just outcompeted, as opposed to, no, they were really destroyed by an environmental catastrophe from an asteroid impact. That was 1980, father and son team of Alvarez and Alvarez. They found the iridium layer. They said, we think this was a global catastrophe. This was an asteroid impact. And if it was big enough to leave an iridium layer around the Earth that all dates to the same age, it would have put enough dust and material up in the atmosphere. The fires would have been enormous. And for these big reptiles, that would have been a death knell. It took a long time for that idea to gain traction. The idea that all the craters on the moon are volcanic. Gene Shoemaker, a man I met. Gene Shoemaker went to Meteor Crater, otherwise known as Barringer Crater in Arizona. He was the first one to examine it and find shot-grain quartz and prove in fact that the meteor crater was what Daniel Barringer originally said it was, a meteor impact, not some kind of volcanic event. When I was a boy, my science book said almost all the craters on the moon are volcanic. It must have been one of the most volcanic places ever. The Apollo astronauts who were trained by Gene Shoemaker, who went up in the late 60s and early 70s, found indeed every crater they found was an impact crater. There are volcanic features on the moon. They are quite rare, and they are massively outnumbered by the impact features. And of course, there's no air or water on the moon, so no weather, no erosion to erase these craters, which is what happens on Earth. Craters don't last a long time here. So the scientific process says, if you've got a valid theory, then your valid theory, two things. One, it should explain everything we know so far. If you've got a new valid theory and it doesn't explain everything we know so far, it's not intact, it's not complete, it's not robust. But just explaining everything we know isn't the gold standard. The second thing, which is the gold standard, friends, that's when a scientific theory makes a mathematically based specific prediction. A good theory doesn't just explain what we know, it points the way to new knowledge. My theory says this, so if you look here, you should find this evidence which my theory predicts. Hubble did this. I've studied. His survey of galaxies was really not that big, about 25 or 6 galaxies. But Hubble was confident in his data, and he said, if you look out at more galaxies, farther away, more distant than I can see, Hubble was confident that our instrumentation would improve. And the space telescope named after him certainly did that. He said, when you look at these more distant galaxies, when new telescopes and new technology become available, you will confirm my theory that the farther away it is, the faster it is moving away from us, because the universe is in fact expanding. This was an extraordinarily bold claim, but it's held up to investigation over the decades since Hubble made that claim in the early 1920s. When Einstein said, oh, I have a new idea about how gravity works, and my theory can explain the orbit of Mercury, and scientists, and gravity bends light, friends, that's what Einstein said. No one took him seriously, except Arthur Eddington in Britain. And Arthur Eddington was a Quaker from Britain who took the German Jewish scientist quite seriously. This was in World War I. Germany wasn't real popular then, friends. And Eddington took Einstein seriously. Of course, he went to the eclipse in Principe off the coast of West Africa in 1919, and his photographs showed that indeed stars were displaced near the limb of the sun during an eclipse by the exact amount which Einstein predicted within the ability of his instruments to measure. And everybody looked at this and said, wow, this is proof of a prediction made by a theory, and this is stunning. This is what made Einstein famous. Interestingly, it made Einstein far more famous than Eddington, who discovered the proof, the first real proof of Einstein's theory. The world is quirky, friends. But when we look at this, we have to have scientific theories based on actual data. And it's perfectly okay to say, you know what? I'm looking at this data and I'm skeptical. I don't think everybody's interpreting this data correctly. Galileo did that. He said, sure, you've got the Earth-centered system, and you've got the epicycles made by Ptolemy, and everybody's been interpreting this, that the Earth is indeed in the center. I think their interpretations are wrong. I think there's a possible new interpretation of the data, and the new theory, which also matches the data, makes this new prediction that differentiates it from the sun-centered theory. The Earth-centered theory and the sun-centered theory made very different predictions about how the phases of Venus should appear. And in fact, before Galileo and his astronomical telescope, nobody had really observed them carefully. It took not only a new idea, but new technology to bring that evidence to light. Realize that the sun-centered and earth-centered system theories had coexisted for millennia. There was no technology to allow any evidence to be gathered that would differentiate between the two. We're seeing a lot of this sort of cutting-edge science going on right now with dark matter. The idea of dark matter is a theory. It was proposed to save the appearances. Vera Rubin found out that galaxies don't orbit the way planetary systems do. In a planetary system, the farther out you go, the slower a planet moves. This is why Jupiter, 5 times farther away from the sun than Earth, takes 12 times as long to go around the sun once. This Keplerian orbit, Vera Rubin found galaxies don't work that way. Things stay at the same speed all the way out. And people immediately said, well, gravity can't be wrong, Newton can't be wrong, Einstein can't be wrong. These were assumptions. They said, well, if Newton and Einstein were right, how does this work? And they came up with the idea of a gigantic, huge, massive shell of dark matter. Nobody could see it, nobody could detect it, didn't seem to interact with anything except gravitationally. And in all the time since Vera Rubin made her discovery, nobody's found dark matter. In fact, every experimental test has come up negative. Nobody's detected it yet. And there are other competing theories out there. Will they gain traction? Will they become more popular? Frankly, Scarlett, as the old movie says, I don't care. That's not the movie quote. You probably know it. What we're looking at here, friends, it's going to take data. These theories, MOND, Modified Newtonian Dynamics from Mordecai Milgram in Israel, and dark matter, which is pretty much everybody else thinks dark matter is the thing. Dark matter is by and far the more popular and more accepted theory than MOND. But when we keep not finding dark matter, people start looking and saying, well, what predictions does MOND make? The trouble is, these theories make predictions sometimes that are not within our technology or just barely. We're pushing our equipment to its ultimate limits, trying to find out. So the last thing people ask is, well, why? And my brother asked me this. I was on the phone with him last week. He said, well, why can't scientists just come out and say what they mean? Be blunt. Just tell us the facts. Well, the thing is, if you're looking at data, you're pushing your equipment to its ultimate limits. The problem is filtering out the signal from the noise. Anybody who's used a telescope knows what I'm talking about. You want to see Jupiter, you want to see the red spot, you want to see the moons orbiting, and the more you magnify, oh gee, well, we're getting a problem. If we want to see the red spot, we often have to push our telescopes to the maximum they will do. They will go, and when we're looking at this, we're finding, goodness, we're having to push our equipment and develop new techniques for observing to pull out that signal from the noise. And when we do this, and when we make scientific measurements, there's always error. Any scientist who says, my data has no error, is not a scientist. They're just somebody being bombastic and trying to make a name for themselves. Genuine scientists acknowledge, oh, here's how much error there is. And many scientific campaigns and experimental campaigns are simply trying to make measurements more precise so we have a better idea. And these error bars, we can say, oh, well, Hubble constant. That's how fast is the universal expansion. And the Hubble constant, well, 68 kilometers per second per megaparsec, plus or minus 5. Well, there's another set of observations which says Hubble constant is closer to 72 than 68. Well, we get these statistics and we say, oh, well, we have confidence. This is why when you go to a doctor and you say, oh, you're going to give me an antibiotic, are you sure it will cure my infection? Well, we're quite sure. We're 95% sure. In 98% of the cases, this drug works as I'm explaining to you, and your infection will be, well, why can't you just say for sure? Because all real science acknowledges error and the possibility that the system is complex and maybe this way it won't work as expected. The idea that we have 90, 95, 99, 99.99% confidence in our data, basically that number is never 100%. And if you see somebody claiming that their theory is 100% absolutely true and perfect, they're being foolish and not scientific. And I gotta say, they're not very well trained in science. And if this person purports to be a professional scientist, I think you're likely to find they're much more likely to be a charlatan than a genuine investigative scientist. All good science acknowledges error. And what do we do in cosmology? In astronomy, we look for, different lines of investigation which give us the same answer. If I'm looking for the Hubble expansion constant and I'm looking with different kinds of evidence, I expect that the universe is only expanding in one way. And so my different lines of investigation should indeed give us the same answer. That cross-checking with different methodologies is what gives us our confidence. It's also what gives us our confidence that Professor Gupta's tired light hypothesis is to a 99% confidence incorrect. That's all we have for you today on How Do You Know? And I hope you've been entertained and informed. And next week, we're going to take a look at the Ingenuity helicopter, the little helicopter that could, and we're going to take a look at some of the science we're doing on Mars and how helicopters are now becoming mainstays in mission planning for new robotic missions to other planets and locations in our solar system. So this is Dr. Daniel Barth for How Do You Know? And the Explore Scientific Company, wishing you a great day. Clear skies, everybody. Bye-bye.
With our exclusive solar viewing glasses. These glasses are not only designed to protect your eyes from the sun's rays, but they're also proudly made in the USA and meet the highest international standards. With comfortable temples and stylish black and gold design, you'll be all set to witness the eclipse in both safety and style. Experience the eclipse with confidence and embrace quality craftsmanship. Explore our solar viewing glasses now, proudly made in the USA for an unparalleled viewing experience.